Hello students, this is Sheetal Lange, working as an assistant professor in St. Paul's College of Pharmacy under the Department of Pharmaceutical Analysis, and today's class is on isomerism, which is the basics of organic chemistry. So the first we need to understand what are the isomers. So isomers are the organic compounds which have same molecular formula but different chemical and physical properties are known as isomers. See, the molecular formula represents how many carbon atoms, how many hydrogens, or some other element which is present in it. By using the same molecular formula, we can prepare two or more organic compounds with same or different functional groups and with different structures also. So here I have given the example of dimethyl ether CH3OCH3, and second example is ethyl alcohol C2H5OH. These both the organic compounds have same molecular formula. You can count the number of carbon atoms in both the organic compounds, same number of hydrogens and oxygen. This phenomenon of existence of two or more compounds with same molecular formula but they have different properties is known as isomerism. See, one compound is acting as a ether and another compound is acting as a alcohol. So as soon as their functional group is changing, their chemical as well physical properties will change. Then coming to the classification of isomerism, it divides into majorly two parts. This first one is structural isomerism and stereoisomerism. The structural isomerism is also known as constitutional isomerism. These are the five types of structural isomerism which I have circled with the little dark blue color. Chain isomerism, position isomerism, functional isomerism, metamerism, and last one keto-enol isomerism, which is also known as tautomerism. And second part is stereoisomerism, in that geometrical isomerism, which is also known as cis and trans, and optical isomerism. Here, structural isomerism is also known as constitutional isomerism. See, I am going to focus on structural isomerism more because it is mentioned in B Pharmacy second same POC 1 subject. So, moving to the next slide. First, we are going to see the definition of structural isomerism. Whenever the organic compounds have same molecular formula but different structures. So what is the difference between molecular formula and structure? Structure means it can be extended chain, cyclic compound, or aromatic ring, which we have discussed in previous lecture. And molecular formula means which represents number of atoms and carbons, hydrogens, or any other element. It is present how many times in your organic compound. So see the definition. It is also known as constitutional isomerism, and definition of structural isomers and isomerism is organic compounds having the same molecular formula but different structures or structural formula. Means the atoms are bonded together is differently. So we'll see the examples here. See, first classification, under that it comes chain isomerism. So all these five types of isomerism and isomers comes under the structural isomers. See, first one is chain isomerism. Chain, by word itself you can understand one after one carbon arrangement. It will look like a chain, is also known as carbon skeleton. So when two or more compounds have similar molecular formula but different carbon skeleton or carbon chain, they are known as chain isomers, and this phenomenon is known as chain isomerism. So I have wrote here three examples. See, in the prefixes in common nomenclature we'll mention n, iso, neo, that depends on the type of carbon skeleton present in your organic molecule. So here three examples I have written which have same molecular formula, that is C5H12 but different chains. So see the first example, that is n-pentane, in which there are 5 carbon atoms join in a straight line. Second example is isopentane. Its IPAC name is 2-methylbutane. In this, you can see second last carbon atom for the iso definition when carries methyl group. Means here first second carbon atom is having branching. This is called as iso position. So the skeleton of N-pentane is different than isopentane. Moving to the neopentane, you can see carbons for all the valencies are occupied with 4 methyl groups or same or different different uh, alkyl groups, you can say. So carbon should be attached with 4 more carbon atoms. Then we will call it as a neopentane, in which quaternary carbon is there. IPAC name of this compound is 2,2 dimethyl propane. So this is chain isomerism. These three compounds are chain isomers of each other. Second type is position isomerism. First we need to define position isomers and then isomerism. When two or more compounds are different in position of substituent atom or functional group on the carbon chain or carbon skeleton are known as position isomers. The name itself indicating position of that group is changing on the chain. The phenomenon is known as position isomerism. Example which have same molecular formula but different carbon skeleton, C3H8O. Other than this example also you can take any functional group or any other molecular formula which can represent two isomers. So in first structure, one propanol means, or you can write propan 1 all, hydroxy group or alcoholic functional group is attached on the first carbon atom. And in second example you can see OH group, that is alcoholic group, is attached on second carbon atom. So name is 2-propanol or propan 2 all. Then third example, functional group isomerism. Functional groups also are isomers of each other. We'll see the definition. Two or more compounds having same molecular formula but different functional groups are known as functional isomers, and the phenomenon is known as functional group isomerism. Here molecular formula C3H6O is one by which we can make two functional groups. So in the first example, C, with the same molecular formula, I have made CH3, C double bond O, CH3. This is the example of ketone. Name is propanone. And another example, CH3, CH2, CHO. This is the functional group. CHO stands for aldehydes, propanol. So here one example is having ketonic functional group and second example is having aldehydic as a functional group. So ketone and aldehydes are functional isomers of each other. Then second example, here C2H6O molecular formula I have used. With the same molecular formula you can represent two functional groups, those are ethers and alcohol. See dimethyl ether, this is the ether functional group, and C2H5OH. In this alcohol is a functional group. So these two compounds are functional group isomers of each other. Then fourth is metamerism. This is called as like unequal distribution of carbon atoms or alkyl groups across the functional group. So here we need the functional groups like which have center oxygen or sulfur, thioethers you can use, then ketones you can use, or you can use ethers also. So I have given the example of ether here, C4H10O, which represents methoxypropane and ethoxyethane. Here common names I have written. They have C2H5O, C2H5 diethyl ether, and next is C3H7O, CH3 methyl propyl ether. So in this you can see in first example across the functional group, that is ether, on left side 2 carbons there and right side 2 carbons, but in second example you can see left side 3 carbon atoms and on right side only one carbon atom. This is called as unequal distribution across the functional group. So this phenomenon is known as metamerism. Here these two examples are metamers of each other. Then tautomerism, which is also known as keto-enol isomerism, and here we will be having the only one structure which can get converts to the another functional group form. See, isomers which can exist in equilibrium and can interchange from one functional group to another. So those functional groups are ketone and enolic form. Are because of that only it is known as keto-enol forms, and those are then these two structures are known as tautomers, and the phenomenon is known as tautomerism or keto-enol isomerism. So I have used here example C3H6O. In this, first we made ketonic form, which is also called as acetone or propanone CH3 C double bond O CH3. See the arrow I have shown, reversible arrows, means keto form can convert into the enolic form, and enolic form also can convert into the keto form. Here carbonyl carbon, that is C double bond O, uh, double bond is present. So the one bond is responsible for one lone pair of electrons or two electrons. So the bond present between carbon and oxygen, from double bond, one bond will shift towards the carbon atom either on left or right side. So on which carbon atom, carbon carbon single bond both the side present, where on which carbon atom or in between which two carbon atoms it is shifting, that time carbon becomes a pentavalent, but carbon is tetravalent or having the valency 4. So that hydrogen atom will get attracted toward the more electronegative oxygen atom which have the lone pair of electron, which helps to make a bond with the hydrogen atom. So in second structure you see enol form, propene to all, in this CH2 double bond OH CH3. In is for alkene and OL for the OH. So this is the simple example of tautomerism. Then coming to the stereoisomerism, which is not mentioned in the syllabus copy of B Pharm second sem POC1, but sometimes the questions have been asked on definitions. So stereoisomerism, nothing but the 3D structure or spatial arrangement of the molecules, organic molecules, the compounds that have the same constitution and sequence of covalent bonds but differ in relative positions of their atoms or groups in space, 3D arrangement. So this special type of isomerism is known as stereoisomerism. It divides into two types, geometrical isomerism and optical isomerism. In geometrical isomerism, you can define it as whenever carbon-carbon double bond is present, then it, if we twist it, it can easily get twisted, but it cannot rotate. So which give the restriction to the rotation of carbon-carbon double bond, which we can see in atomic model construction. Next I have kept the picture, and this illustrate that restricted rotation of atoms or groups around the doubly bonded carbon atoms gives rise to different geometries of such compounds. The stereoisomers are known as geometrical isomers, and the phenomenon is geometrical isomerism. Cis and trans, these are the two types. See, first cis one, isomers in which two identical atoms or groups which are present on one side of double bond, either upside or downside. Then those are cis isomers, and when they are bonded on the carbon atoms which are doubly bonded with each other on opposite sides, one is on upper side, one is on another side, but on adjacent carbon atoms, not on same carbon atoms, then we can say it as a trans isomers. Whenever the positions are changing, either cis or trans, their melting point, boiling point, dipole moment, solubility, all these parameters are going to change. See, in this, I have made these atomic models. First one is 2-butene. Also, I have written here cis 2-butene in the CH3 C double bond C CH3. Reversible structure, just we need to twist it, then you will get the trans 2-butene. So, whatever I have written here, the structures, same we have made in the atomic construction. When you are holding this atomic models and trying to rotate it completely, it will not allow to rotate complete double bonds. But if it is a single bond, you can rotate two carbon atoms. But here double bond will give the restriction for the rotation. Due to that, there is a formation of two isomers. See first pic in that, this is a cis 2 butene, and in second pic you can see both the CH3 groups are antiplanar, means opposite to the each other in opposite planes also. So another example I have mentioned here. Here this is having, you can consider this group as a OH. On first carbon, black color balls are carbons and white color balls are hydrogens. Red color is O, oxygen, OH. So here in the cis form, both the OH groups are on one side of double bond, and here now both are OH groups opposite to each other, that is trans form. Then optical isomerism. Normally when we switch on the light in home, ordinary light spreads in complete room and we will get the like light in the room or visibility. But plane polarized light means when we are passing this ordinary light through the Nicol prism, all the rays of light runs or direct in the same direction. Then we will call it as a plane polarized light, PPL. Then the angle by which the plane polarized light is rotated, that will be measured, and the instrument is known as polarimeter. So whenever we are placing the material in which your sample to be analyzed, or you want to determine whether your sample is dextrorotatory or levorotatory, that will be placed into the polarimeter. And when you are passing the light through this, then how your sample reacts with that light. See, if the compound rotates the plane polarized light towards the right, that is clockwise direction, however clock goes, the likewise it is known as dextrorotatory compound, and for that compound name we'll mention with a prefix small d or positive sign or capital D. Then if that light will be rotated towards the left anti-clockwise direction, then that compound will be known as levorotatory compound, and before that compound's name will mention L, small l or negative sign, or capital L we will denote. And this dextrorotatory and levorotatory are optical isomers, and the phenomenon is known as optical isomerism. See, we have seen many energy boosting drinks. In that, D glucose is used for instant energy. So have you heard about the glucon D? So it is the dextroisomer of the glucose, but glucon L is not there. See, there are some compounds just with the rotation of light their properties will change. So medications having rotation and isomers, those are optical isomers of each other, also have medicinal values. So one isomer, one optical isomer will be having medicinal value, but another will not be having. So depends on that. D glucose and L glucose, out of this D glucose is used for instant energy. So I have made here structures also. Any queries, then post in the comment section. And thank you for watching my video. Kindly subscribe my channel and be connected for more updates and more coming videos. Thank you so much.